let's look at an example where I can use some of the values in a triangle to identify the other values. And this in particular uses a special triangle, 30, 60, 90 triangle. So I have a model of a Ferris wheel where I'm told that the angle theta is 30 degrees and that the radius of the Ferris wheel is 100 feet. And I have these missing quantities that I want to find x and y. And they must not be exact values. The author says, let's round this to the nearest tenth of a foot. Okay, so let's think about a 30, 60, 90 triangle. This isn't exactly 30 degrees, but how do we go from the long side to the short side to the hypotenuse? A 30, 60, 90 right triangle. We go from the short side to the long side by multiplying by root 3, and we go from the long side to the short side by dividing by the square root of 3. So if this radius is 100, then this side from C to F, this length from C to F is 114 feet. I can use that as a new 30, 60, 90 triangle. And the value of a similar triangle says I go from the long side to the short side in this version of the 30, 60, 90, the same way as I do from here to here. I just divide by square root of 3. So this means y is equal to 114 divided by the square root of 3. On a calculator, approximately I have 65.8 feet. How do I use that information to find out what x is? Remember, r is 100. So this hypotenuse is 100 plus x. And in the 30, 60, 90, I go from the short leg to the hypotenuse by multiplying by 2. So 2 times this number is 100 plus x. Now let's not abbreviate or approximate yet. I can solve that for x just by subtracting 100. X is 228, that's 2 times 114 divided by the square root of 3, minus, make sure I subtract correctly, 100. That's the exact answer. Just like this is the exact answer. 114 divided by root 3. But I can also approximate. So I'll double that y and subtract 100. It's 31.6 feet, approximately. Always answer exactly when you can, and then approximately when someone asks you to approximate to a certain accuracy.